Okay, we will solve the next one. The next one will be number 5. We have matrix R, 2 by 2 matrix. We need to find R square. We need to describe geometric transformation represented by R square and geometric transformation represented by R, and write down what is R to the power of 8. So let's solve this one. Okay, just a second. Okay, so once you see this type of matrix, you should immediately notice that these numbers, they look like trigonometrical values, something like sine of 45 degrees or cosine of 45 degrees. And once you see this type of matrices, for example, it can be here a square root of 3 over 2 or something like this. So usually you should remember about rotation matrix right away. And as we described earlier, what is a rotation matrix? If you have xy axis, and assuming you rotate everything with respect to origin by some angle beta, you rotate everything. You rotate every vector, like vector A is an old vector, you get to the vector H, it's a new vector after rotation. And this sort of rotation around origin by an angle beta, it has its own matrix. And this matrix always looks like cosine beta minus sine beta and sine beta. It's very easy to remember, but you know, I will show you later how not to remember it. You can always derive it. But in this case, it is a rotation matrix. Rotation with respect to origin by an angle beta. And what is the point of this matrix? It's very important to understand. We have a coordinates of an old vector. Let's write it like this. Coordinates of an old vector before rotation. It is an old vector and we have it before rotation. And we have a new vector h that we get after rotation, hx, hy. It is a new vector that we get after rotation. And the main idea that matrix R allows us to get the coordinates of a new vector after rotation from these coordinates, from old coordinates. So in order to get the new coordinates, this one, we need to just take all coordinates and multiply it by this matrix. And this is it. So let's write it down explicitly. So the new coordinates, h, x, h, y, it is a new coordinates after rotation, okay, equals, you need to take this matrix, cosine beta minus sine beta, cosine beta. You take this matrix, it's matrix R, times coordinates of an old vector, ax, ay. This is it. And it is a common thing in linear algebra that you have like old vector, you make some transformation and you get a new vector, and in order to get a new vector you should multiply coordinates by this sort of matrix, in this case matrix R. And we can write it very quickly like this. We can write it like hx hy column equals R times ax ay. This is it. It is a rotational matrix R. And in this case, just remember this form, and we should look here. And you can immediately see that it is a matrix of rotation around the region by 45 degrees. We can write it here. It is a rotation by 45 degrees around the region. So in this case, we immediately can say that describe the geometric transformation represented by R. We already did it, right? And it's absolutely normal thing that once you solve this type of problems, you do not solve them like from the start. You at first try to understand what it's all about, and once you kind of, once you have a better understanding, you can answer all these questions one by one. But after that, you can see that they ask us to find R square and R to the power of 8, and it's very simple to do. You do not need to perform really any calculations. So let's take this equality, okay? And once again, what happens here? We take old vector A and we multiply it by this matrix. Basically, when it happens, we rotate an old vector by 45 degrees and we get a new vector after rotation here. So let's multiply it once more by r from both sides. So we make it like this: r hx hy equals r times ax ay. So what we see here? Here we see that we take a new vector hx hy, basically vector h, and we multiply it from the left side by matrix R. Basically, we rotate new vector by 45 degrees. So we can write it here. It is a rotation of h by 45 degrees. Okay? And here, what we see, we can rewrite it as r square times ax ay. Okay? So once again, we need to understand what happened here. The rotation of a new vector by 45 degrees is here, but the new vector h, x, and y is a rotation of an old vector by also 45 degrees. So it's kind of, double rotation of, let's write it down, and h is a rotation of a by 45 degrees. So basically what happened here, we rotate new vector by 45 degrees, but the new vector itself is a rotation of an old vector by 45 degrees. Basically, this one, what happens here, that we rotated the old vector 2 times by 45 degrees, and this kind of, this action is a rotation of an old vector by 90 degrees. So it is a rotation of a by 90 degrees. So basically we rotate a by 90 degrees, and it is actually exactly the same as multiply vector a by r square from the left side. So the main idea that I want you to remember, we already discussed it in the previous lesson, that rotation of a by 90 degrees, it is exactly the same as to take vector a with its components and multiply it on the left side by r square. So if we multiply it by r, it would be a rotation by 45 degrees, okay? It is a rotation by 45 degrees with respect to origin. But once we multiply it by r square, it would be a rotation by 90 degrees with respect to origin. So once we have 2 here, it means 2 rotation by 45 degrees. Very simple to understand, and so here it will help us to understand how to solve our problem here. So find r square. Of course we can multiply this matrix by itself, but in the same way we can say that r square, it is actually a rotation not by 45 degrees but two times, but by 90 degrees with respect to origin. So we will write it r square is rotation by 90 degrees with respect to origin. So I will not write it to the end. So what is the matrix of rotation by 90 degrees with respect to origin? We have it here. Let's look. You can see rotation by an angle beta is this sort of matrix. In this case, we speak about beta equals 90 degrees. So let's write it down. So it would be cosine beta, cosine 90 degrees minus sine of 90 degrees, sine of 90 degrees, and cosine of 90 degrees, okay? It would be exactly r square. Once again, we figured out that r square is a rotation by 45 degrees 2 times. It is the same as rotation by 90 degrees with respect to origin, and it should be represented by this matrix in case when beta is 90 degrees. Cosine of 90 degrees is exactly 0. Here would be minus 1, 1, and 0 again. Okay, so r square is this one. Okay. Describe the geometric transformation represented by r square. Once again, we already described it. We already talked about it. We can say that it is a rotation with respect to origin by 90 degrees. And the last one, write down r to the power of 8. And again, it would be very inconvenient for us to multiply this matrix by itself 8 different times. So it's very tedious. But once again, we talked with you just now that r square is rotation by 45 by 90 degrees. In the same case, we can multiply it 3 times by r here. We would take this equality and multiply it by r here and by r here, and we would get in the similar manner we would get that r cube is actually a rotation by 45 degrees times 3. So r cube is actually a rotation by 135 degrees with respect to origin, and so on and so on. And by analogy, you can understand that r to the power of 8, this one, r to the power of 8, is actually a matrix of rotation, with respect to origin, of course, by 45 degrees times 8, because like the power of 8 here, 45 degrees times 8, and it would be exactly 360 degrees. So it is a matrix of complete rotation. And of course, this is a matrix of rotation by 360 degrees, and it should be represented like this. And in our case, beta angle is 360. And let's write down what would it be. So r to the power of 8 equals cosine 360 minus sine 360, sine 360, and again cosine 360. Let's calculate this matrix. Cosine 360 is obviously 1, and here sine 360, it's obviously 0, 0, 1. So r to the power of 8 is actually standard unit matrix. Okay, so this is it. It concludes this problem. As you can see, we solved it in the next way. So at first we understood what this matrix is all about, and after that we could very simply answer all these problems. So I will save this paper and I can send it to you. And so this is it. Let's go to the next one, number 6.